How a motorcycle engine works, 4-stroke cycle explained. Most motorcycles use a single-cylinder, 4-stroke petrol engine. The transparent cutaway animations you're seeing show exactly how every part moves and works together inside the engine. This 4-stroke cycle, also called the Otto cycle, was developed by Nicolaus Otto in the 1860s and is still the foundation of nearly all petrol engines today. Main components visible in the video. Cylinder and piston. The cylinder is the hollow chamber where the piston moves up and down. The piston has rings around it that seal the combustion chamber and prevent gas leakage. It connects to the crankshaft through the connecting rod. Crankshaft. This is the engine's main rotating shaft. It converts the piston's straight line, reciprocating motion into rotary motion. Power from the crankshaft goes to the gearbox and then to the rear wheel via the chain and sprocket. Valves, intake and exhaust located in the cylinder head. These two valves control gas flow. The intake valve lets fresh fuel air mixture in, and the exhaust valve lets burnt gases out. Both valves are controlled by the camshaft. Camshaft and timing chain/gears. The camshaft has lobes, bumps, that push the valves open at the exact right moment. It's connected to the crankshaft by a timing chain or gears, ensuring perfect synchronization between piston position and valve operation. If this timing is off, the piston can hit the valves and destroy the engine. Spark plug, mounted in the center of the cylinder head. Its job is to produce a high-voltage spark that ignites the compressed fuel-air mixture. Clutch and gearbox, visible on the right side of the video. The clutch connects or disconnects engine power from the gearbox when you pull the clutch lever. The gearbox has 5 gears to adjust speed and torque. Oil circulation. Golden-colored oil circulates through the entire engine. It's critical for lubrication coating the piston, crankshaft, camshaft, gears, and bearings. Without oil, friction would seize the engine within minutes. The 4-stroke cycle step by step. 1. Intake stroke suction. The piston moves from top dead center DTs down to bottom dead center DS. The camshaft opens the intake valve. A vacuum forms inside the cylinder and pulls in the fuel-air mixture from the carburetor/throttle body. The crankshaft rotates half a turn 180 degrees. 2. Compression stroke. The intake valve closes. The piston moves back up from DS to DTs, compressing the fuel-air mixture to about 1/8 to 1/10 of its original volume 8:1:10:1 compression ratio. This compression raises the mixture temperature to 300 to 400 degrees Celsius. Both valves stay closed. Crankshaft completes one full rotation 360 degrees. 3. Power stroke combustion. Just before the piston reaches DTs, the spark plug fires. The compressed mixture ignites a controlled explosion that reaches 2000 degrees Celsius and creates 40 to 60 bars of pressure. This pressure forces the piston down hard. This is the only stroke that produces power. Both valves remain closed. Crankshaft reaches 540 degrees. 4. Exhaust stroke. After delivering power, the camshaft opens the exhaust valve. The piston moves back up from DS to DTs, pushing the burnt gases CO2, H2O, Colorado, knocks out through the exhaust port. Crankshaft completes 2 full rotations 720 degrees and the cycle starts again. What makes a bike engine different? A car engine has 6 cylinders that fire in sequence, getting smooth power delivery. A bike engine has only 1 cylinder, so it produces power only once every 2 crankshaft rotations. That's why bike engines vibrate more, and why they use a heavy flywheel on the magneto side. The flywheel's inertia carries the engine through the free non-power strokes. When you kickstart the bike, you're manually rotating the crankshaft. After 2 free rotations, fuel-air mixture enters the cylinder, the spark plug fires, and the engine starts running on its own. Final point. The transparent engine models you see in these videos are educational, but they work exactly like the real engine in your motorcycle. From 70cc commuter bikes to 150cc street bikes, CD70, Kick 125, Buyer 125, Guests 150, etc. Almost all use the same 4-stroke single-cylinder design. The only differences are displacement, cylinder volume, compression ratio, and fuel system, carburetor versus fuel injection, but the cycle stays the same. Intake, compression, Power. Exhaust. This cycle repeats 800 to 10,000 times per minute RPM while you ride. That's what's happening inside your engine every time you twist the throttle.